some typical complex numbers. The knowledge of or your familiarity with the some typical complex number really helps you at times in saving your time and solving very complicated kind of problems. Okay? You people know that the way you guys have learned some typical right angle triangles. For example, you know that 3, 4, 5. This is a very famous, these are the very famous sides of a right angle triangle. So now imagine a student who knows that if this is 3, this is 5, then what is going to be this side? So a student knows that this is 4. There is another student who is applying the Pythagoras theorem to find this side. So you see that who is saving the time? The one who knows that 3, 4, 5 is a typical right angle triangle. Similarly, you also have been told to learn the values of, like, 0, 30 degrees, uh, 45 degrees, 60 degrees, and then 90 degrees, the values of these angles for the sine, cos, and tan. Now the ones who have learned these values, they are the ones who can save uh, their time a lot, and they can do much more quickly than the others who are dependent on their calculators. Okay? Now, similarly, with respect to the modulus and the argument, we have some typical complex numbers that you can easily recall that what is the argument or the modulus of these uh, complex numbers. Now, suppose if you have a complex number z, which is 3 plus 4 iota, or you have a complex number u, which is 5 minus 12 iota, or they're the combinations of 3s and 4s, 5s and 12s, and maybe 6 and 8. Can you tell me quickly what is the modulus of this 3 plus 4 iota?
5.
Yeah, that is 5, because this is again very much related to this, because this modulus formula is directly dependent on the Pythagoras theorem. Okay, and what is the modulus of this u over here?
13.
That is 13. Okay, so this one is 13. Now, similarly, you can have a complex number. Let's say there is a complex number w, which is just 7. So what is its modulus?
7.
That is 7, because if you look at its, I mean, 3, 4, 5, 6, 7. So you're marking this as your point A, and here is the O, the origin. So you see that this OA length is 7. So the modulus of this W is 7. Now imagine there is a complex number U, which is minus 5 iota. So what is the modulus of this complex number U? Sorry, this is,
5.
if u is minus 5 iota, then the modulus of u is going to be 5. Because again, if you look at its Argand diagrams, is 1, 2, 3, 4, 5. So you have minus 5 iota over here. So the modulus is going to be, this length is going to be 5. Okay, so the thing is that you must be able to figure out to tell the modulus, if you can tell that mentally by just looking at the real and the imaginary parts. Okay, so this was about the modulus thing, and now for the argument thing. Now if you have a complex number which is a plus iota b, let's say there is a complex number which is this z is a plus iota b. So you know that the argument is going to be tan inverse of b over a. Achha. Again, as I had drawn a table over here, if you remember the tans values, like if you have this 0, and then this is pi by 6, pi by 4, pi by 3, and then pi by 2. You know that tan 0 is 0, tan pi by 6 is 1 over under root 3. This is 1, this is under root 3, and this is infinity. Okay, so This is 1 over under root 3. Acha. Now, suppose you have a complex number, which is, let's say u is 5 plus 5 iota. Can you tell that what is its argument without using a calculator? Hmm? If you use this formula, you see this becomes 5 over 5. What is 5 over 5? That is 1. So that means the argument is going to be this pi by 4. Okay? So the argument of u is going to be pi by 4. Now imagine that instead of this 5 plus 5 iota, you have a complex number which is 3 minus 3 iota, or there is a complex number w which is minus 2 plus 2 iota, or there is a complex number p which is minus 5 minus 5 iota. In general, if you have a plus iota a, you see that this is going to be a over a. So in all these cases, you will see that your argument is going to be a multiple of pi by 4. Let's see how this is. So now suppose this is your imaginary axis, the real axis, okay? And now you have this 5 plus 5 iota. Look at this. This is 5 and this is 5. So this is going to be over here. So you see that what is 5 over 5? Tan inverse of 5 over 5 is tan inverse of 1. So this angle is going to be pi by 4. So the argument of u is pi by 4. Now look at this v, 3 minus 3. So this is 3 minus 3. So this is going to be in this quadrant, 3 minus 3. That is your fourth quadrant, okay? Like this. So what is going to be this argument? Yes, who will tell me what is the argument of v? Hmm? Yes? Bacho, soge? What is the argument of v? Minus pi by 4, because this is going to be a clockwise direction. This was an anti-clockwise direction, okay? Now look at this minus 5 and minus 5. Minus 5 and minus 5. So this will be here, minus 5 and minus 5. So you will have it here in this direction, okay? So this is your pi by 4. So how much is the argument here? Hmm? Yes? What is argument of P? क्यों बच्चों? Argument of P is, come on yaar, where are you people?
Minus 3 by 4 pi.
4 pi or minus 3 pi by 4. Okay, now look at this minus 2 plus 2 iota. So this is minus 2 here and this is 2 over here. So you go in this direction. So you know that this is going to be pi by 4. So how much is going to be this, this argument here? Hmm? So what is R? That is 3 pi by 4. Argument of W is 3 pi by 4. Okay. Now, similarly, if you have, let's say, now, let's say you have complex number like this. There is z is under root 3 plus iota, or u is 2 under root 3 minus 2 iota, or v is minus 5 under root 3 minus 5 iota. Now look at all these, or in general, let's say your p is a under root 3 plus a iota. So again, that table, you know that if there is 0, so this is 0. If this is pi by 6, so this is 1 over under root 3. So I'll be focusing on this. Now look at this. If you try to find the argument here, so let me draw that here. Now, if it is, let's just take this example over here, okay? This can be a under root 3 and it can be over here, okay? And if it is my a under root 3 minus a, it would be somewhere over here, okay? Like this. Yes. And then you have minus a under root 3 and plus a iota. So this is minus over here, and this will be something like this. And for minus a under root 3 minus a iota, you will have it over here. Okay. So this is your a under root 3. This is your minus a under root 3. This is your a. This is your minus a. So when you find this tan inverse of a over a under root 3, so you see one a's are cancelled. So what are you left with? Hmm? Yes, Pacho? Come on, yeah. This is 1 over under root 3. So what is tan inverse of 1 over under root 3? That has to be this pi by 6. So this is, if they are both positive, like here, this argument of z is going to be pi by 6. Okay. In this case, when this is, which quadrant is it? This is 2 under root 3 and then minus 2. Which quadrant is it, Bacho? Hmm? Yes? Second, third, fourth, which quadrant?
Fourth.
Fourth quadrant. So we are clear that the angle is going to be pi by 6. So the argument of u is going to be minus pi by 6. Okay. Now look at this this one here. This v. Which quadrant is this? Hmm? Both of them are minus. Hmm? Yes?
Third.
Yeah, that is third here. So this is pi by 6 over here. So what is going to be this angle? Hmm? Yes? That is minus 5 pi.
5 pi by 6.
So, and for this one over here, when you have, let's say, there is a complex number q, which is minus 2 under root 3, and then plus 2 iota. So which quadrant is that? Hmm? Yes? First, second, third, fourth, which quadrant? Hmm. Come on, yaar, bacho.
Second.
That is the second quadrant because this is minus, this is plus. So we are in the second quadrant over here. And we are again clear that this angle is going to be pi by 6. So how much is this argument here? Yes, that is 5 pi by 6. Or if you keep this as 30 degrees, so this angle is going to be 150 degrees. If you keep this 30 degrees here, so this angle is going to be minus 150 degrees. This one is 30 degrees and this one over here is minus 30 degrees. So we remain between 0 to pi or 0 to minus pi or 0 to 180 or 0 to minus 180. Okay, now you try the next one. Let me give you here. Okay, now imagine instead of this, now you have something like, let's say your z is 2 plus 2 under root 3 iota, or your u is minus 5 plus 5 under root 3 iota, or your v is minus 5 minus, let me keep minus 5 here, and then your w is um, 5 minus 5 under root 3 iota. So again, if you look at this theta, so this was 0, we have discussed pi by 3, we have discussed pi by 4, and now this is going to be pi by 3. So this tan theta is going to be under root 3. So you see, whenever you find that tan inverse of b over a, in all of these 4 cases, this can be plus or minus under root 3. So the argument would be in terms of this pi by 3. So let's go through this quickly. In fact, you try this first, and then I'll tell you that how this is going to be. Now this is going to be, now this would be shorter, this part, and this would be longer because the angle has to be 60 degrees. Okay. So this can be like this, sorry. This can be like this. This can be like this. Okay. So now, when you write this tan inverse of B over A, as I just told you that this is going to be like, if you look, just take this example here. This is going to be tan inverse of 2 under root 3 over 2. The 2's are cancelled, so just under root 3 left. So this is going to be pi by 3. You can write this as pi by 3, or you can also say this is going to be 60 degrees. When you talk about this, which quadrant is this, bacho? Minus 5 plus 5 under 3 iota?
Second.
Second quadrant, okay? So I just write here pi by 3. So what would be this angle? That is pi minus pi by 3.
120 degrees.
Or in radians, that could be 2 pi by
2 pi by 3.
1. Now, which quadrant is this? Minus 5 under root 3.
Third quadrant.
Third quadrant, yes. So this is going to be pi by 3 here. So this is going to be either like this argument of B is minus 2 pi by 3, or this is minus 120 degrees. Okay? And for the last one, this argument of W, you see that this is going to fall into the fourth quadrant. So this angle is simply pi by 3. And I write here minus pi by 3, okay? Because this is going to be clockwise, or this is minus 60 degrees. So that is how you find the, you can find these arguments mentally when you look at that this B over A can be simplified as under root 3, and tan inverse of under root 3 is pi by 3. Now we have to talk about this last segment, which is when it is pi by 2, and this is going to be infinity. Now, these are the cases when you have like something like this. Let me, um, and this. Okay. Can someone tell that what kind of the complex number would this be when we have this infinity? I mean, the argument is 90 degrees. Yes? Anyone, give me a complex number whose argument is 90 degrees or pi by 2. Yes? No? Yes? I could not hear you.
Sir, 5 iota.
Yeah, very good. This is, let's say 5 iota. Look at this. By just drawing this, you see that this is 5 over here. So from this to this angle is simply 90 degrees. Can you give me a complex number whose argument is minus pi by 2? Yes. Minus pi by 2. Come on. If it is,
Sir, minus 5
minus 5 iota maybe. So you see that this is 1, 2, 3, 4, 5 here. This is minus 5 iota. So there is no need to go for any calculations. This is simply going to be argument of U is going to be minus pi by 2 or minus 90 degrees. Is anyone here confused? Okay, if you're not confused, then I give you the argument of a complex number W that is pi. Can you tell me what can be this complex number? Give any value of this. Okay, where were we? So we were here. Okay, when the link broke, I was asking you that suppose you're given that the argument of a complex number W is pi. So can you tell me what can be any possible values of this W?
Sir, -4.
Very good, beta. Like if it is -4 over here, so you see that all of this is going to be pi. So that is -4. When can this be 0? For example, there is a complex number P and its argument is 0. इसके लिए क्या
Sir,
होगा?
जब +4 होगा.
Yeah, +4 or +5 or whatever. So this is going to be 4. Okay, like if it is just here 1, 2, 3, 4 here, so this argument is going to be 0 degrees or 0 radians. ठीक है, I have explained you, in fact, shared with you the typical complex numbers. Okay, now let's go on to the next segment.